This is 1.6, describing pairs of angles, a continuation of 1.5. Remember I said that 1.5 has a lot of angles, and we're just going to continue into 1.6. So the first pair of angles that we're going to talk about are vertical angles. Vertical angles are two angles that are across from each other and are congruent. Now, if we look at this diagram up above here, what we can see is that we're going to have angles that are across from each other and are congruent. So the first pair that I'll talk about are angle 1 and angle 3. If we were to go ahead and write these on a piece of paper and fold them hamburger style on the vertex, making these lines here on top of each other, we would see that these angles here, angle 1 and angle 3, would be the exact same angle. So with that said, angle 1 is congruent to angle 3 because of vertical angles. Now, the other pair that we have in this diagram also include angle 4 and angle 2. Again, same concept. If we were saying, okay, if we fold these, if we had drawn this diagram on a piece of paper and folded them on the vertex, in this case, hot dog style, we would go ahead and see that these two angles are congruent to each other. So angle 4 is congruent to angle 2. And again, the reason for that is because of vertical angles. All right, the next term that we're going to talk about is adjacent angles. And if you know that definition or you recognize that word, adjacent angles, adjacent just simply means next to each other. So when we talk about adjacent angles, we're talking about angles that are next to each other. So in this picture, this diagram here, we're talking about angle A and angle B. These are adjacent angles. And the reason why they're adjacent angles is because they share a ray with each other. So again, angle A is adjacent to angle B. Now, there isn't any real math or geometry part that will help us solve for these angles. It's just that sometimes they'll give us information about certain types of angles that maybe they'll identify as, oh, find two adjacent angles or two non-adjacent angles. So if they say non-adjacent, they're referring to two angles that are not next to each other. So non-adjacent, not next to each other. Now this will help us lead into the rest of the angles that we're talking about. So let's go ahead and jump in. All right, we have two more sets of angles that we're going to be using a lot through the rest of the year. And the first one is supplementary angles. So supplementary angles are two angles whose measure have the sum of 180 degrees. So what they're saying is that this angle here plus this angle here, so again, talking about this angle here plus that angle, are going to add up and equal to 180. You'll notice again, if we do 40 plus 140, well, yes, that does equal 180. We can also remember that this angle here kind of looks like, well, it actually does look like the one that we talked about in 1.5, which is referring to the straight angle. Now, going to this next diagram, the angle here is 60 degrees and this one is 120. So again, supplementary just means 60 plus 120. It's definitely going to equal to 180. And so that's what makes these two angles supplementary. You will notice though that these angles don't have to be, going back to our terms, right? They don't have to be adjacent. This angle and this angle, they are adjacent. So these are adjacent, and again, adjacent means next to each other. But you'll notice here in this diagram, these two angles are non-adjacent. They're not next to each other. So the angles do not have to be next to each other in order for them to be supplementary. All that needs to be said is that the two angles are going to have the sum of 180. All right. So, previous vocabulary word, complementary angles is very similar. We're talking about two angles whose measure have the sum of 90. So in this case, we're not talking about 180, we're talking about 90 degrees. And so what they're saying is the same thing. All you need is to have two angles, two different angles that are going to add up and equal to 90. So in this case, in this picture, you have 40 plus 50 is going to equal to 90. So these two angles are going to be called supplementary. So they come in pairs, and we need to make sure that we refer to them as a pair, as a set. So the next set, you'll see again 27 and 63. Well, once again, you'll see that 27 plus 63, that's going to equal to 90 degrees. So complementary means the same thing, that you don't actually have to have them adjacent. They just have to have the sum of 90 degrees. So you'll notice that this first diagram includes a set of adjacent, and the second one is a set of non-adjacent. And they don't have to be next to, or they can be. Now in 1.5, we actually touched on angle bisector, so we're just going to recap on all that information and write down the actual definition. We know what bisecting means. We know what that word means, and we also know what angle means now because of 1.5. So we're just putting it all together, and we're saying is a ray that bisects an angle in two congruent coplanar angles. So you'll notice here the bisector is ray KM. So if they ever wanted you to identify the bisector, you can say ray KM is my bisector. And whenever we have congruent angles, because again, what does the bisector do? It cuts angles in half, right? If we ever have congruent objects, we need to write down a congruent statement. So that's what we're going to do right now. We're going to first state that angle LKM is congruent to angle MKJ. So angle LKM, which is this angle, is congruent to MKJ. All right. So again, we're just recapping on what we learned from 1.5. All right, our next term is linear pair. So we're talking about two angles that are adjacent and supplementary. So in this case, a linear pair is very similar to our supplementary angles, but supplementary means that we don't have to have an adjacent or non-adjacent. They can be either. They can fall under adjacent or non-adjacent. And with a linear pair, they have to be adjacent. So I'm going to go ahead and underline that so you remember. It has to be adjacent. And of course, they have to also be supplementary. And last but not least, we're talking about two angles, right? So like we've done in the past with the angle addition postulate, we're going to go ahead and write down a linear pair, a statement with it. So what we're going to go ahead and start with is angle ABD plus angle DBC is equal to angle ABC. So a linear pair is going to fall under that, right? So once again, angle ABD plus angle DBC is all equal to angle ABC. Yes, it is just stating the statement about the linear pair, saying that these two angles added up together are going to equal to 180 degrees, but putting it in the angle addition postulate. So key things you have to remember, that they are adjacent and they are supplementary. All right, so that brings us to our first example. So you're going to be given an example like this where it says angle KPL. So this angle here, angle KPL, and angle JPL, this angle here, JPL, are a linear pair. So when they say linear pair, we're talking about two angles that are adjacent and they are supplementary. So automatically, linear pair, adjacent, and supplementary. So you'll write your statement down like we've done in the past. We're going to first write down, let me continue with the statement. It says, the measure of angle KPL is equal to 2x plus 24. And the measure of angle JPL is equal to 4x plus 36. what are the measures of each of these? So they want you to find what the measures are. They want you to find what angle KPL is, and they want you to find what LPJ or JPL. So we're going to go ahead and start there. But remember, we always have to write the geometry part first. So we're going to write angle KPL plus angle JPL is equal to angle KPJ. Now at this time, I'm going to go ahead and let you press pause and go ahead and solve the problem on your own. So remember, key things that you have to think about is that if it says linear pair, they have to be adjacent and they are supplementary. All right, so press pause and go ahead and solve for it. I'm pretty certain that gave you enough time to go ahead and, do the problem because you pressed pause. So let's go ahead and begin. So the equation is 2x plus 24 plus 4x plus 36 is equal to 180 degrees. Because it's a linear pair, we know that they are going to be supplementary. So here we go. We're going to go ahead and just solve. We're going to combine our like terms, which you already did, right? You're going to do 2x plus 4x. And 2x plus 4x, that's going to be 6x. And I'm going to combine 24 plus 36. I'm going to subtract 60 from both sides. And we're left with 6x is equal to 20. Divide by 6 from both sides of the equation. And x is equal to 20. Now, remember, they didn't ask us to find what x was equal to. They asked us to find the angles. So that's what I have to do. So I'm going to go ahead and plug in 2 times 20, because that's the information that we found, the 20, plus 24. And this is going to be 40 plus 24. And so this finally is going to be 64. Again, I don't actually have to do that by plugging into the second one, but I'm going to this time. You could just simply subtract by 180 and 64 to get the missing angle. But I'm going to go ahead and do that, plug it in. So 4 times 20 plus 36, and 4 times 20 is 80 plus 36. And that's going to add up and equal to 116. So really, I should see that 116 plus 64 is going to equal to 180. And that, so far, we have 180 is a true statement. So these two are the correct answers. You do have to tell me that those are the angles. And let's go ahead and finish our last problem. So our last example says, what are 2 vertical angles? Okay, so what I'm going to ask you to do right now is press pause and try to find 2 vertical angles on your own. When you find them, what you're going to go ahead and do is write a statement. So you're going to, for instance, say angle, and this is just an example. You're going to say angle ABC, and it's not relevant to this diagram. So angle ABC is congruent to angle CDE. So again, this isn't actually true, but that's what I'm looking for. I'm looking for a congruent statement. And you would say also because of vertical angles. So make sure you say all this information when you're stating your vertical angles. So please press pause because, like I mentioned, this is not an actual true statement for the picture that we have here. All right, I think you pressed pause and you gave this a try. So let's go ahead and go with our first example. Our first pair of vertical angles. I think we only have 1 pair, but we can see if we have more. All right, so I see that angle CFG and angle AFE, these angles are vertical, which makes them also congruent. So these angles, angle CFD is congruent to angle AFE. So if this angle here is 62 degrees, which is angle AFE, then angle CFD has to equal the same thing, which is 62 degrees. So it says find two missing angles. So that means I found one missing angle. This angle here was missing. So I found this angle. And if you notice, there's one more angle that is missing, which is that one right there. So in order for me to find that missing angle, I have to use the information I know. Okay, what information I know? I know that I have two angles here. I have 28 and 62, these two angles here. I want to see if they are complementary. What does complementary mean? It means two angles whose sum of the measure is 90. So let's see. If I add them, that's going to be, yes, they do equal to 90. So if that means that this angle here is 90, there's technically an invisible box that's not there, which also means that this angle has to be 90. How do I know that? Well, again, what do I see? I notice that this angle here, which I'm going to take away these blue highlights for a second. I notice, that this angle here is a straight angle. And because that's a straight angle, what I'm going to do is simply subtract, well, again, I added those two angles, so I'm going to subtract 180 minus 90, and that's going to give me 90. And that is why this angle here is also 90 degrees. All right, I hope that helps.